Good morning, everyone. Welcome. Thank you for joining us for this lecture event, the 17th annual lecture on informatics, which also happens to be the third pre-conclave lecture of Library Technology Conclave 2021, which is the fifth in the series. I am Shalini Aras, Program Chair of Library Technology Conclave 2021, and your host today. Just a little housekeeping before we get started. Please be mindful of the microphone. Keep it muted. Unmute when you are speaking. If you have any questions during the presentation, please type them into the question box in your Zoom control panel. I will bring them up during the audience question and answer session. Now, without further ado, I request Mr. N.V. Satyanarayana, the brain and the force, the event and informatics, to deliver his welcome address. Over to you, Satya.
Thank you, Shalini. Good morning, friends. My hearty welcome to all of you audience to our 17th annual lecture on informatics, which is being organized as the third pre-conclave lecture of the Library Technology Conclave 2021. The conclave is in 21 years, but what we are having is a series of pre-conclave programs. The current COVID situation has encouraged us to innovate, organizing this program in a different way of scheduling all the conclave programs in a series of webinars. It's my pleasant duty and privilege to invite our speakers, Professor Jayant Haritsa, and our chair for the program today, Professor Balaram. I welcome you, sir. I also welcome the discussants, who are a group of panelists here, 5 members, who will be having a dialogue with the speaker after the speaker completes his lecture. Welcome to you all, sir. I also welcome the guest invitees. I also welcome my friends on the core team of LTC 2021, a small team of about 11 people who are helping in putting together this program. Once again, I welcome you all for this program. As I welcome all of you, I also welcome the representatives of our partner organization. LTC 2021 is organized jointly by Informatics, NIAS, that is National Institute for Advanced Studies, Bangalore, CSR 4 Paradigm Institute, and Rajiv Gandhi University of Health Sciences, Bangalore. A few words about Library Technology Conclave. This is the 5th in the series, which we started 5 years ago. Why did we start Library Technology Conclave? You know, our own vision is evolving in our business, and you know, the library is a place for knowledge and information. We look at information and knowledge as shapeless. They keep taking the shape of the media all the time, depending on what media is current. And the media where information and knowledge is curated and propagated is always driven by technology, and more so extensively and intensively in these days. So we thought of creating this conclave with this intent. This particular conclave, as I said, is in two parts. We had three pre-conclave lectures. The first lecture was delivered by, which we called it curtain riser lecture, by Professor Brahmachari on the topic E-Science and the Fourth Paradigm in Research, which represents the theme of the conclave 2 very aptly. The second was delivered by Professor Prasanajit Mitra, the Associate Dean of Research for Penn State University, on digital libraries and research data management. Today is the third lecture, which is also the 17th annual lecture on informatics. The topic being data science, the good, the bad, and the ugly. I will come to that more. And we have two workshops, pre-conclave workshops scheduled for 7 January on AI for e-science and on 8 January on ontology for data management. The actual conclave will be held from 27 to 30th January. And on each day, there will be 2 sessions. You will hear more about the conclave. Please watch our website. Friends, once again, welcome to annual lecture on informatics, 17th annual lecture. The topic being data science, the good, the bad, and the ugly. A few words about the annual lecture itself. We instituted this lecture series as part of our company's 10th anniversary celebration several years ago. The focus of this lecture series is to invite eminent speakers to address the current challenges and emerging trends in information science and technology. The first lecture was delivered by Dr. N. Sheshagiri on 18th May 1990. Subsequently, we had the privilege of 26 distinguished speakers from India and abroad delivering this lecture series talks, which includes Dr. Balaram, who is presiding over today's function, people like Dr. Mashalkar, Ms. Rian Mittal, Professor Ramaswamy, who was DG CSIR, Dr. Gio Vidarod from Stanford University, Anand Girish, Chief Editor of Journal of Information Science, and like that. Today's distinguished speaker is Professor Jayant Haritsa. Friends, I have pleasure in introducing Professor Jayant Haritsa. He is a brilliant speaker and a humorous, and also a very humorous speaker. You will really love to enjoy hearing him. He is a distinguished alumnus of IIT Madras, did his MS from the PhD from the University of Wisconsin in the field of computer sciences. Back in India, at IISc, he founded the database systems in 1995. His work predominantly lies in the intersection of database systems and data mining, with a focus on query processing across a range of database systems. He has several recognition. He got his best paper award at the International Conference on VDLB, that's a very large database, in 1998. In the same conference, he won the award for Best Software Demonstration in 2010 and 2014, that's twice. He is the proud recipient of the prestigious Shanti Swarup Bhatnagar Award in 2019. And he is also a distinguished scientist of ACM Award in 2009. He is a fellow of 3 academies in India, that's Indian Academy of Sciences, Indian National Academy of Engineering, and National Academy of Sciences. And he is also the fellow of IEEE. And he received the most prestigious Infosys Science Foundation Laureate Award in Engineering and Computer Sciences in 2014. Professor Jayant, as I said, is a very brilliant speaker, and he brings in a flavor of his passion for cricket in his talk, which you would love to hear. He also looks a bit like Salman Khan, and he is more handsome than Salman Khan. Thank you, Professor Jayant Haritsa, for agreeing to deliver this lecture. This lecture is chaired by Professor Balaram, a distinguished scientist, and he is a very powerful speaker. And he's powerful because he is very thoughtful as well as thought-provoking in his lecture. Professor Balaram's journey of his education and career started in Pune with his graduation in chemistry, moving to IIT Kanpur for doing his master's, and then to Carnegie Mellon University for his PhD and for postdoctoral research at Harvard University, where he worked with Nobel laureates. And back in India, he joined IISc, the Department of Molecular Biophysics there, and he also became the director of IISc in 2005-2009, from 2005 to 2009. He continues his research in IISc and also at NCBS Bangalore. Professor Balaram received his Padma Bhushan in 2014, the prestigious the national award. He also received his Bhatnagar Award in 1986 and the Third World Academy of Science Award in 1994. All of us remember always Professor Balaram as the editor of Current Science and his regular columns in Current Science, the brilliant columns and thought-provoking columns, which is something we all miss and the scientific community is missing. Thank you, Professor Balaram, for agreeing to chair the session of the day and deliver the presidential address. Welcome again. Friends, a few words about informatics. You know, we are celebrating 40th year. We started like a startup in 1980 when there were no startups. And we had our roller coaster years in the last 40 years, but we are where we are today, a happy company. And I must say that in this many years, in this year of COVID, the company, although has faced a lot of difficulties, as our Prime Minister said, we did not, we maintained all the staff and paid the salary to all the staff. Although I may also add that the government, while the Prime Minister told everybody, all the companies, perhaps he forgot to tell his government that the company should be paid on time. So, friends, informatics had an excellent journey and a memorable journey. More to share much later about informatics journey. To briefly introduce informatics, I request my colleague Sanjay Grover to present a 2 minutes multimedia on informatics. Once again, I welcome you all.
Thank you, Satya. Devendra, can I share my screen?
40 years ago, when information was scarce and online was unheard of, informatics was envisioned with a digital vision by an entrepreneur working as a librarian then to bridge the global information access gap in the country. This pioneering vision is a global company today with products and services benefiting millions of users in the academic, research, and corporate segments around the world. India Today magazine described the venture as the first online information company in India for global knowledge access. Serving global information companies on a project for supplying consolidated Indian business information helped Informatics to ideate its first digital information product named India Business Insight, IBI. Credited with the enviable reputation as the pioneers in the online and CD-ROM-based information business in India, Informatics started creating new digital information products through 1990s. Neuromed on CD, a product initiative funded by NIMHANS Bangalore, was the earliest e-journal archive in India for Indian medical journals. Driven by the internet advantage, Informatics developed its first global information product named JGate. JGate is truly the world's largest database for journal literature by its coverage of over 50,000 journals. The journey has continued with a diverse portfolio of products and services, evolving across 4 business units: information products, digital library solutions, enterprise content management and publishing. The product family of Informatics is a growing list, with innovation driven by the latest in technology and evolving market needs. In an industry where content is the king and technology is the master, Informatics has been a proud pioneer and leading player. Gaining 40 years of insightful experience by 2020, Informatics continues to be driven by values with a passion to deliver excellence.
Yeah, so that was a small, brief presentation on informatics. Now over to you, Satya.
Thank you, Satya, and thank you, Sanjay. Now I would like to request Professor Balaram to take over this session, the floor, as chair and initiate the proceedings. Over to you, Professor Balaram.
Thank you very much, Shalini. I'm really privileged to be able to chair this informatics lecture, especially when it's been given by a longtime colleague of mine at the Indian Institute of Science, Professor Jayant Haritsa. He's already been introduced to you. And I think looking at his title, I think in addition to his many other accomplishments, he also likes Hollywood Western cowboy films. And I hope that the lecture that we are about to hear will be filled with humor and also be understandable to those of us who are not really data scientists in the truest sense. May I now request Professor Haritsa to give the 17th annual informatics lecture.
So is the screen visible now?
Yes, sir, it is visible.
Okay, so can I get started?
Sure, sir.
Sure. Okay, so firstly, thank you, Dr. Satyanarayana, for the extremely kind introduction and the invitation to deliver this lecture, despite the insult to Salman Khan. And good morning to all of you. And I should also say that I am honored to be part of a session where Professor Balaram, who has been a mentor for many of us at the Institute, is the chair of the program. Okay. Data science has today become the buzzword of choice, especially in the software industry, and it is projected to provide great and wondrous solutions to all our contemporary societal challenges. However, while it can certainly be a potent force multiplier, it is equally subject to methodological abuse, leading to erroneous and even potentially dangerous conclusions. So in this talk, what I'll try to do is to provide a more nuanced and balanced view of the area. A popular view of the evolution of the scientific method, which you will also see on the Conclave web portal, is that it has gone through these 4 stages of evolution that you see listed here, beginning with empiricism, where you just observe the data, then moving on to theory, where you try to come up with mathematical explanations of the observed data, and then with the advent of high-speed computing in the last century, the synthesis of data through programs. And now in today's information age, where data is essentially become the genesis of science. What is actually also interesting is that this fourth stage or four paradigms was actually initially propounded by Jim Gray, who happens to be the patron saint of the research area that I work in, which is database management systems. And Jim Gray is also a Turing awardee, which is the equivalent of the Nobel Prize in computer science. Now, in this evolutionary history, what is interesting to note is that the role of data has moved from being part of the output all the way to the input now. And although this role reversal is celebrated by many, there is also a danger that it could lead us to the proverbial situation of putting the cart before the horse. And this is the thesis that I will try to present in this talk. So, but before that, let's first define data science itself. And if we go to Wikipedia, which is the fount of all wisdom today, it defines data science as essentially a multidisciplinary field that uses the scientific platform in order to extract knowledge and insights from data coming in a variety of formats. And those of you old enough to remember the venerable field of or discipline of statistics would wonder what is the difference between the two. Well, if your statistics was primarily looking behind your shoulder and trying to explain whatever events have occurred in the past. So it was analyzing the prior data, and it was largely a manual exercise because of the lack of technology at the time. And most of the data that they had was fairly limited because it was also difficult to collect this information and to get it into a digitized form. So typically what was happening is that due to the lack of computing resources also, it was a one-shot exercise where you computed various kinds of statistical parameters on the observed data. Now, if you move to data science, the difference is that while statistics was looking at the past, data science is trying to predict the future. So in a sense, it's your homegrown astrologer. The only difference is that between astrology and data science is that astrology is probably more accurate. So now that I have made my biases evident, so let me go on and also say that the reason that data science has become so prolific and common in usage is that there have been two major advances over the last 50 years. One is high-speed computing and the other is sensor information. So using both of these inputs, now we can actually do iterative analysis of the data that we have, and therefore can come up with various kinds of predictive mechanisms for estimating as to what are the kinds of trajectories that this same data may follow in the future. But underlying this all, still I would say that data science is essentially statistics, but on steroids. And just to convey this, there is a nice cartoon on the web, which shows you how statistics can move on to data science. And it starts with this picture of this person just looking at statistics on the wall. But then based on the audience with whom he is interacting, the name changes. So when you are initially implementing it, it is just called as logistic regression because you don't want to pay your software developers too much. But when you're hiring them, you call it as machine learning because you want to attract them to the company. And then when you're fundraising from the venture capitalists, it's called as artificial intelligence. But underlying all this is, as I said, the venerable discipline of statistics. Okay. So now we in India are extremely fond of crediting to ourselves all the major technological advances, including plastic surgery and wireless technology and so on. All of you know what I'm referring to. But for the most part, this is just wishful and jingoistic thinking. However, you might be surprised that to know that with data science at least, some legitimate credit can be claimed by the ancient Indians. In particular, this notion of Drig-Ganita Ekya. And what this essentially means is that you want to make sure that what you observe, there's Drig part, matches with the computation that you do. And the ekya is the oneness between the two. So the idea here is when it was initially propounded was being used in the context of astronomy, and you wanted to predict where the stars and the planets would be present at any given time. So what is interesting to note here is that this approach to astronomy was diametrically different to the Greek or the Hellenic approach, because here there are no models, there are no deductions, there are no theories, there's no philosophies. It is just saying that let me make sure that whatever I compute is accurate. Whereas in the Greek approach, they were trying to come up with unifying models. For example, they would say that all the planets move in circular orbits and so on. And what we have is a situation where essentially it's Aryabhatta versus Ptolemy. And this has been extensively studied by Professor Rudam Narasimha, who is a household name in the country, known to many of you, and the doyen of the aerospace industry in the country. So he had a very nice article in the Economics and Political Weekly in 2003, which I would highly recommend all of you to read, which talks about these two different approaches in pursuit of the exact sciences. Okay, so with that historical background, now I'll come back to the title of the talk, which said that data science, the good, the bad, and the ugly. Since we have 5 discussants here who are all evangelists for data science, I thought what I would do is to outsource the good part to them, and we will wait for the discussion session to hear more about the useful aspects of data science. And you would also have heard of the similar contributions through the earlier conclave talks of Professor Brahmachari and Professor Mitra and so on. So instead, what I will do is to immediately jump to the bad and the ugly, which always is a lot more fun. Okay? Now that we are in the world of Arnab Goswami, we all know that this is the new norm, where it's great fun to cast aspersions on the various kinds of politically correct ideologies. Okay, so let's start with what is happening in India currently. Yeah. You'll find that there is a remarkable amount of hype about data science. And so, for example, if you look at this slide, and Quora is a web portal which is frequented by most of the students in India, okay, where they ask questions as to who are the tough professors at IISc and so on, who are the ones who give easy grades, and very important information like this. There is a write-up by the project manager for one of the important data science companies, which starts off with this disarming statement saying, data science, no background required. And the first line says that graduates who are not from the STEM backgrounds can also become data scientists. There are no hurdles as such to move on from whatever background you had into the data science world. Also says that beginners and non-programmers should ideally start by learning programming, and a various set of tools are listed there, including Python, Tableau, Excel, MySQL, and so on. And then once you have survived this initial experience of learning programming, you can then follow on to advanced learning in these steps. They're very helpful there. They say in the first step, try to advance your programming capabilities. Yeah. And I really like the fact that this is, they don't insist on it. They just say, try to do it. And if it works out, more power to you. And then in the second step, it says, try to gain some knowledge of intermediate statistics and probability, and also how machine learning algorithms and methods are used. There is also a note of caution. It says, focus on just a few machine learning algorithms. And again, try. Okay? Doesn't insist, try to understand how they're applied. And in the third step, you are now let loose on the real world, test your advanced analytics and machine learning skills, and use data sets from well-known platforms like Kaggle. Let's look at the coaching academies, which several of whom are also hosted in Bangalore. Does it take you much time to become a data scientist? Not at all. You can get it in a jiffy. The data science boot camps are just 3 months in duration. And it is not that you have to actually spend the entire 3 months with them. It is only on weekends. So you can keep your day job, and on weekends, whenever Netflix or Amazon Prime is not operating and the IPL is out of commission, then you can come and to our boot camps. And at the end of the boot camp, what is the outcome? You would have mastered all three elements. Okay, and I'm just lifting all of this directly from the advertisement, so I'm not making up any of this. You would have become the master of all three elements of data science, statistics, programming tools, and business knowledge. And as a bonus, they will also give you professional assistance and guidance on how to craft your resume and identify the job opportunities. My suspicion is that most of the 3 months will be spent in the resume building exercise and leaving the mastery to others. And then what about the kinds of skill sets that are required from data scientists? This is a survey done by a very well-known magazine. And what they say is that, look, data science is being used in industries across the spectrum. So data scientists are expected to have a broad set of skills. And they've actually outlined these skills as well. And if you go through them, you find that they primarily talk about various kinds of programming tools and platforms. So Python, Tableau, RStudio, which is an integrated development environment, then Hadoop, which is the common distributed systems platform for map-reduce kinds of computational tasks, and so on. Yeah. The important thing to note in all of this is that the entire emphasis is on quickly becoming a good programmer. But what is important to realize in data science, which is sadly lost often, is that the key word in data science is not data. The key word is science. Data is the input to in which the science could be evaluated, but we should not substitute science with data. And in fact, data science requires a deep understanding of the underlying physical and mathematical principles, as well as the data domain, and not just the programming tools and environments. And in this context, there was a wonderful quote from Professor Ronald Coase, who won the Nobel Prize in Economics in 1991. And what he said was that if you torture the data long enough, it will confess to anything. And what he meant by that is it's important to first have a scientific hypothesis and not just jump into the data and start swimming around saying, I found something interesting. Okay, so now let's see in what ways does this emphasis on primarily the programming aspects and not on the methodological aspects and the scientific foundations, in what way does it affect the outcomes? So let me start with an article that appeared in the op-ed page of the New York Times in 2014. And the authors are Professors Marcus and Davis, who are computer science faculty at New York University. And the title is provocative. It talks about several problems with big data. And what they say is that big data is prone to giving scientific sounding solutions to hopelessly imprecise questions. Essentially, what they mean is that big data encourages you to ask the wrong questions. So in research, we know what is more important than giving the right answer is to come up with the right questions. And what they are saying is that big data encourages you to ask the wrong questions. And a particularly compelling example of this phenomena is that there was a study done by groups from MIT and Google. And what they did was to say that we want to rank all the historical figures. Nowadays, as you know, ranking is the name of the game through the entire government as well as industry. And unfortunately, even academia has fallen prey to this completely sterile exercise of comparing institutions. And what they've said is that let's try to rank all the historical figures, saying who had the most impact on the world. And how did they do this? They essentially went through all the websites and looked at how many references there were to these various well-known figures. Okay. Obviously, you'll not be surprised to know that Jesus Christ ranked first. But later on, as you go down the list, you will see that Hitler ranks higher than Aristotle. I'm sure that Aristotle would be turning in his grave at fairly high angular frequency at knowing that Hitler has a higher impact on the world than the philosophies that he had propounded. But this is again a bogus conclusion. It's just because there are a lot more web pages about Hitler. Aristotle, unfortunately, was born too many years ago and therefore does not figure as prominently on the web as Hitler. So essentially, what is happening is that we need to ensure that big data does not become huge nonsense. Now, there is the University of Washington at Seattle, which is a very well-known research university, especially well-known for computer science. And there are two professors in the computer science department there, Professor Bergstrom, actually Bergstrom is from biology, and Professor West, who is a data scientist. And a few years ago, they started a new course, which is titled Calling Bullshit in the Age of Big Data. At first sight, when you look at the title, you might think that this is an April Fool's kind of a joke, given the scatological nature of the contents, and this is just a joke. But actually, it is a serious 3-credit course. And they have been running it for the last 4 years now, and there's several creditors for it. They also have a book that has come out of it. And what they say is that earlier in the scholarly discourse, you had a lot of nonsense coming through. And this was usually in the form of big words and fancy rhetoric. But more and more, we see it presented today in the guise of big data and fancy algorithms. And what they try to do in this course is to essentially look at it forensically and point out how people often make very simple and elementary mistakes in coming to conclusions based on data analysis. So there are several wonderful examples on the website that they have. There are case studies, and I highly recommend you to all go and have a look at them as well. I'll just show you a few sample ones from the site. The first one is very simple. It looks at this advertisement, and it says that, look at this cocoa mix from Nestle, which is 99.9% caffeine-free. Okay? It sounds, oh, it looks very good, and I'm not going to kill myself by drinking this chocolate mix. But then if you actually go and look at the details, you find that even strong coffee, the type that you get in Starbucks, is also 99.9% caffeine-free. And that's very simply just because caffeine is an extremely potent drug, even in small quantities. So by definition, pretty much everything would be 99.9% caffeine-free. So now you might say, okay, fine, but this is a silly example because all of us know that we should never trust in advertising, and this has to be taken with a large quantity of salt. So this really doesn't make your case. Okay? So now let me move on to something which actually appeared in the Nature journal, which, as you would know, is the acme of scientific journals, especially in the basic sciences. Yeah. So what they did was to look at, and this is a group from Oxford University, and they said that, let me go and look at all the winning times, that is those who won the gold medal at the Olympics for both men and women in the 100-meter dash. And they looked at it over the course of the essentially the last 100 years. So as you can see in this graph, it goes from 1900 onwards. And they have plotted all the points here. So you see the red points which correspond to women, and then the blue points which correspond to men. And here, as you can see, the scale goes from essentially 8 to 13 seconds. And what they wanted to look at is, can we fit a straight line to the performances that we have seen over the last century? And based on that, try to extrapolate and make some new conclusions. So what they did is, so just look at this red line and this blue line, ignore the yellow line and the green line because they refer to something else. So they took this red line and the blue line, so blue line for men and red line for women. And as you'll see that the slope for women is more than that for men. And based on this, they came up with the conclusion that in about 120 years or so, women will beat men for the first time, because you see that these two lines are now crossing at around 2156. Okay? Now you can continue the same kind of a logic and take the argument to its absurd end by saying that in just about 600 years, if we are all still alive in spite of global warming, the times of less than 0 seconds will be recorded, because at that point in time, it will cross the x-axis. So which means that you will complete the race even before it started, and even Usain Bolt may have a hard time matching this performance. So the point here is that the extrapolation to the future is a very dangerous exercise when you don't know what the subsequent behavior will be. And in fact, the professors from University of Washington, Seattle looked at some additional data points since the study was published. And these are the light green and the orange points that you see here. And you can see that things are flattening out for the women. Okay? And this is what is to be expected, is that things will not progress in this nice linear narrative. At some stage or the other, basic body mechanics will take over and it will flatten out. But this kind of conclusion that women will beat men in about 120 years time has been published in a journal as prestigious as Nature. So the bottom line here is that we tend to ignore reality and simply work backwards from the data, and in the process violate many fundamental principles. Now here is another example, and this I really love. This is a study done by a professor at the University of Sydney in Australia. And it's a study which looks at music and specifically musicians. And it's a fairly morbid study. It looks at when do these musicians die. Yeah. Maybe based on their performance, she was not particularly thrilled of them staying for to a ripe old age. And she actually studied at what age do musicians die. And they were segregated based on the kind of music they were playing. Okay, so as you can see in this graph, on the x-axis, you have the blues, jazz, country, and so on, all the way down to rap and hip hop. On the y-axis, you have the average age at death of musicians who are from each of these different schools of music. And the title of the article is literally Music to Die For. Okay? And what they have done is to look at this again for both men and women. So you'll see the blue is the male musicians. Blue is the male musicians, female is the yellow colored graph. And to give you a comparison, the average expectancy for generic males and females is also shown at the top of the graph. So if you look at this graph, what you will see is that those musicians who are in the classical stream like blues and jazz and so on, they all live long. But for those who are in the more contemporary schools of music like rap and metal, what you find is that they tend to live, they don't tend to live that long and they die much earlier. The underlying subtext here is that we know that in these newer schools of music, they lead licentious lifestyles, and therefore, in a sense, they probably also deserve to die early. So if you wanted to translate this to the Indian context, you could say that the blues and jazz correspond to singing bhajans and Carnatic music. Those of you familiar with Carnatic music would know that many of them live very long. You have Shamangudi Srinivas Iyer, you have R.K. Srikantan, all living close to 100. And at the other end, you have the new Bhangra and Bollywood music with people like Yo-Yo, Hani Singha, and so on, who have a very different lifestyle. Yeah? And therefore should be expected to not live that long as compared to the other classical forms of music. And when the study was first published, people also commented that this came in the Washington Post, that this is worse than war. We don't even lose half our army in a battle, whereas here you have lost half your musicians at a very early age itself. But this is a completely bogus kind of a conclusion. Okay? The reason that this is bogus is, if you look at these recent genres of music like metal, rap, and so on, they are very recent. So the data that you're looking at does not showcase the long-term age at death, but only those of these young set of musicians who happen to have premature deaths. Okay? And what has been done also, so this is the first mistake. And the second mistake which has been done by our media is that the average age at death was converted to life expectancy, because this is a much easier term to understand, but it is in fact technically incorrect here. And then in the next analysis that they do, they drill down into the sources of these various kinds of deaths, and you'll find that you have the coronary and cancer related illnesses which lead to death, and then you have the lifestyle based deaths occurring or mediums of death occurring because of accidents or suicides and homicides. And again, what you will notice is that for all the classical musical schools, most of it happens because you just live long enough and your body gives up at various stages. But if you look at the more recent kinds of music, okay, so there is a note of disapproval here already, then you will find that many of them have leading lifestyles that would not be politically correct and therefore die of these unnatural causes like suicides, homicides, and accidents. Okay? But again, there is a technical mistake here. It is not the lifetime probability of each cause of death that's being measured here, but a conditional probability based on the probability of death at the time of the study. Okay? And as I said earlier, some of the genres of music are very recent. Therefore, the conclusions you draw about them cannot be extrapolated to what you did with the classical schools of music. And finally, what you have is that this genre-specific mortality is confounded with the age distribution. Okay? There's a lot more detail in the website itself, and you can go and have a look at it. But the point is that basic mistakes are being made. Okay? And one of the most fundamental mistakes, although all statisticians would be very well aware of this, is that there is a confusion between what is correlation and what is causality. And in this particular case, the causality that they're trying to draw is to say that based on the musical genre, that determines your age of death. Yeah? And it's quite possible that these are just correlated attributes and not causal attributes. And even if you just consider correlation, there is a hidden variable here where based on this specific school of music that you belong to, there's also likelihood of which age distribution you belong to. Yeah? And therefore, you need to actually look at the age of death of those who have already died. So this study actually got a lot of publicity, and people said that, yes, if you went back to the classics, you'll live long, but if you insist on being modern, then you're putting your life in grave danger. So that's the incorrect kind of conclusions that have been drawn from this exercise. So you might say that was in the sports and the entertainment industry. What about the scientists? So here is a grant allocation which was done by the National Institutes of Health, which is the primary equivalent of the DBT in the US. And what they said is, we want to find out how many grants should we give to each investigator. And they did a detailed analysis where they tried to compare as to the number of allocations that I give you, what is your return on performance? And that is shown on the graph that you see on the left side here. On the x-axis is essentially the amount of money that you are given. On the y-axis is the number of citations that you had. Okay? So in a way, they're using citations as a measure of productivity and saying that as I put in more and more money into you, how does your productivity change as a function of the investment? And what the NIH actually did, and this policy was operational for a couple of years, after drawing this particular graph, they said that, look, after about investment of about 3 grants, you find that it starts flattening out here. Therefore, it means that any additional grant is not giving you much bang for the buck. So let me stop at about 3 or 4 grants per investigator and not give them more than that. Okay, and as a proof for their, and there was also a very insidious kind of intuition that would subscribe to the same claim, because you would say that if I give you more and more grants, then it's likely that you have less and less time to spend on it. So because your time is split across many projects, obviously your productivity is going to suffer because the quality of the work goes down, and therefore we should just stop at 3 or 4 grants. And the final proof was given in the form of the concavity of this return of investment grant. So citations via funding. But what you may not have noticed is that this is a log-log graph. And concavity in the log-log space does not imply linear concavity. In fact, it doesn't do in this case. There are several investigators who, the more money you give them, do better and better, because they can then hire more postdocs to do the work for them. Right? So the point to note here is that the graph is, first of all, making a mistake of plotting this on the wrong scale. The second is that they are taking results over a population, the average results over a population, and using that to determine individual behavior, which is the classical mistake to make in statistics. Is you cannot extrapolate from a stereotype to an individual. So here, the composite results are being used to predict individual behavior, and that is completely incorrect. Okay? And so if you look at the details of what was done in this study, they essentially do a multiplication of two distributions, And on one side, there is a conditional distribution which gets replaced by an absolute distribution on the other side, which is statistically incorrect. Okay, now since Professor Balaram was the chair here, and I know that he's a chemist at heart, I also thought let me show an example from basic sciences itself. So about 2 years ago, there was this article on predicting reaction performance in carbon-nitrogen cross-coupling using machine learning techniques. And this is again by a group from a very celebrated university that is at Princeton, and appeared in Science, which is the other extremely popular journal in the basic sciences, in April 2018. And what they did was that they studied the impact of isoxazole additives on reaction poisoning during the Buchwald-Hartwig coupling. This is a popular technique used in pharmaceutical or drug synthesis. And the conclusion at the end of the study was that an advanced machine learning technique called as decision forests worked much better than just a simplistic linear regression of the kind that we saw before. And it also successfully applied to both sparse training sets, because it's hard to get a large amount of data here, as well as out of the sample prediction, that is the ability to generalize to new data that, or to new inputs that you had not seen previously. So this looks wonderful, and in fact looks like a poster boy for how machine learning can help scientists. But then just a few months later, this is in November 2018, there is a group from the University of California at San Francisco in the same journal where they comment that if you took the earlier experiments from the Princeton group and replaced all the measured values of the chemical features, like the resonance shifts, the dipole moments, and all these other kinds of bonding related information, and instead just throw in junk values. Okay, so you just put in random values here. It still produced a model that had similar performance to the Princeton outcomes. So what it essentially means is that the importance of these additive features cannot be distinguished from some hidden structure that already exists within the data set. Okay, so that was just about saying that we might have made some mistakes and fanciful assumptions and conclusions and so on. Can it really hurt? Okay, so I'll just give you a few examples of how actually data science could be dangerous, not just wrong. So there's a wonderful book called The Weapons of Math Destruction, and this is by Cathy O'Neill from Wall Street. This was published about 5 years ago. And it talks about how data science can actually increase inequality and is a threat to democracy. And this is because our lives increasingly depend on our ability to make our case to machines. And with this COVID situation now, pretty much everything has become digital, and all of you would have seen that in order to make any kinds of payments, whether it's for electricity, water, or any other kind of purchases, everything depends on our ability to make our case to machines. There is no human in the loop here. And one of the examples that she gives is that there is an Australian organization for administrating welfare to people who are unemployed and in a poverty-stricken situation, and this is called a Centrelink. And they have an automated compliance system which compares the income that is reported by those who are desiring this help to the information held by the taxation office, because they want to make sure that only the right people get these benefits. But what has happened is that based on some information that was given by the clients, which corresponded to a couple of months in the year, they did an extrapolation to the entire year. And as you know, much of the workplace is run by seasonal distributions. Therefore, they came up with these completely incorrect assumptions regarding income distribution across the year based on the behavior on a couple of, which was seen in a couple of months. And due to this, many deserving candidates for this support were actually unfairly penalized and did not receive this help. Another example of the problems with data science is that you could also land up with self-fulfilling prophecies. So for example, a loan denial because of having a faulty risk model is more likely to be denied again when you apply to the next bank. Okay, so you try with SBI and you try with Canara Bank, and then you go to the Yes Bank, okay, which is probably the only bank now which is going to give you a loan. This is because it is on record now that you have been refused credit previously. So we usually fall into this trap where you say that, look, everybody else said this guy shouldn't be given a loan, so why should I do it? And then you say, I will also not do it. And pretty soon the domino effect ensures that you will never ever get a loan again. And the same kind of a situation also occurred with regard to policing, where you find that the predictive policing, which is very common, especially in the US, based on demographics and backgrounds, can actually alienate the innocent targets to where they actually start behaving the way they were suspected to be. Because if you say that I'm going to be treated this way, irrespective of whether I committed some incorrect act or not, you might say that let me at least do it and deserve this abuse, rather than being a decent citizen but still being susceptible to such kinds of ill-informed attacks from the various government agencies. Same thing was also happened in Starbucks. They tried to use these various kinds of scheduling and assembly line techniques, where people were essentially being called 10 minutes before they were supposed to start work and saying, show up now. Many of the workers they had were people, especially single mothers with babies and so on, who used to find it extremely difficult now to come and also gain their employment. And people started becoming treated like machine parts. And Starbucks actually publicly apologized for this subsequently, but this happened for quite some time. We also have this current danger, which most of you would have seen at firsthand. If you are part of WhatsApp, you will see that news is spread very fast, and usually it's the fake news because that's the most titillating and interesting. So you can modulate the news feed algorithms to selectively push an opinion slant or pander to a particular section of society. And often people give you various kinds of fake news that confuse the issues by looking at photographs that were taken from some other context and sticking it into the current scenario and saying this is what has happened today. And you find that when people actually do the fact checks, most of these are wrong. There's also various kinds of peer pressures that are exerted, Facebook's likes and so on. And therefore, what happens is that you are trying to modulate the behavior of society by trying to push a particular kind of agenda here. So in conclusion, I hope that I have been able to convey to you that while certainly data science has a lot of good about it, and as I said, this is a very one-sided presentation that I've made just because there is a subsequent discussion session and you had the previous talks, but at the same time also wanted to highlight the fact that we in India often tend to fall prey to these buzzwords and say that, oh, I'll become a data scientist in just 3 months, and after that I will be giving Gyan to the rest of the world. Most of the time, what you would be doing is A, asking the wrong questions, and B, giving the wrong answers as well. Okay? So in conclusion, what I would like to point out is that data science is certainly very useful, but it has to be carefully used. It should be a tool of last resort to validate a hypothesis and not first. So you should not jump into the data and say, tell me something interesting, because it will invariably tell you something interesting, which is equally wrong. So this is what was mentioned in the New York Times op-ed article as well, is that if you have so much data, you tend to start asking the wrong questions. And since the data is so large, you will also not realize that you're making several mistakes in the conclusions. And the second point is that the tool is a support, very powerful support, no doubt, but it cannot substitute for domain expertise. So if you are a chemist, for example, you would hopefully have seen through the earlier example that we showed about the pharmaceutical synthesis that many of these things, although they look extremely alluring to say that I use the most modern techniques to figure out things that had previously not been known, are often wrong and are contrary to basic science. And therefore, we should be very careful in not substituting domain knowledge with support. Certainly the programming tools are very useful, the platforms are excellent, and there's no question of that. But this is one of the weapons in your arsenal, but should not change gut feeling, which is probably the most important requirement for any good scientist. Finally, we should ensure that all our tool outputs, and this relates to the issue of fairness, should be compliant with science and not predefined biases that most of us suffer from. And we are going to be trying to push various agendas. So there is a lot of work that is going on currently to look at how do you ensure that most of the data science works in a reasonably fair manner, where your inherent biases are not in some sense also automatically reflected in the data or the algorithms that are being used to process the data. Okay, so with that, I'll end my presentation. And I now know that there is going to be a discussion session where there are more critics than even the Spanish Inquisition. So I'll get ready for that now. So thank you for your patient listening. and we can now move on to the discussion session.
Thank you, Jayant. What a lecture. It was simple, scholarly, and of course, full of satire. We now have the dialogue with discussants session. So now, first, I would like to call upon our first discussant, Professor Vidyadhar Mutkavi, who is the head of the CSIR Fourth Paradigm Institute, to join the dialogue with his question.
Thank you very much, Professor Shalini, and thank you very much, Professor Haritsa, for your talk. I just wanted to ask you a two-part question. Actually, it's a disjoint to two parts, not this thing. I just want your comment. I understand that, when the definition that you provided from Wikipedia on the data science, there are two keywords used. The one is the knowledge and the other one is insight. While I understand information has a formal definition in computer science, I may be wrong, but knowledge and insight really don't have. So does it really provide a sound definition is one part question. You may want to look at it as a comment or can take it up as a discussion. But
Yeah,
my second real question, maybe we can take the two into this thing. See, doesn't data science serve the purpose of filling that gap in our math model and the real world that it is trying to actually emulate?
right.
So isn't it, doesn't it serve the purpose of filling that gap by a combination of physics-based models and data models? So isn't that great, not just good?
Right.
Okay.
So Professor Mutkavi is a computational fluid dynamicist. So it's obviously clear where his heart is, and what he actually said is very true. Whatever I presented here was an extremely one-sided view of the world, but that's just to balance the rest of the hoopla surrounding data science. And what he was asking in the second part of his question is that doesn't data science have an important role to bridge the gap between the coarse mathematical models that we often have to develop, because it's very intractable to get perfect solutions. So we often make simplifying assumptions, for example, something like a uniform distribution, and saying that things are being done in a graduated manner and so on. So many of those assumptions which are not matching with reality could be bridged with the data science approach. That's certainly true in the sense that if you want to use data science as a tuning process for the mathematical models, I think it's a perfect solution. So you have the model, and you often find that they have parameters to be set. In the machine learning world, these are the hyperparameters that you need to come up with. So all that kind of fine-grained tuning that you require to make sure that in spite of these various assumptions that you made, that you have not lost the meat of the problem, but you still have essentially retained the core, the scientific kinds of trajectories that are being followed by the various methods that you are following. As long as you can ensure that, then data science comes in as a force multiplier at the end, where you have a basic system in place and then you fine tune it using this notion. But if we did it from the starting point itself, there is a danger that we get swallowed by the data without trying to see whether it is even compliant with, for example, Newton's laws of motion. And as I was mentioning yesterday, even in the Georgia Tech, which has one of the best computational science departments in the world, they have deliberately made sure that in every floor that has computer scientists, there's also a physicist in the same floor, just to make sure that we don't violate basic laws of nature while coming up with these artificial claims about very surprising and novel behavior that had been completely unexpected. Now, coming to your first part of your question, which was about the definitional aspect. Yeah, so I would say that it's at least important to realize that data science at best can give you knowledge, but certainly cannot give you wisdom. And the wisdom comes with a lot of experience in the field. And that is where I was saying is that you need domain expertise. It's not that the computer scientist can go and solve chemist's problems tomorrow. Okay? Although we may think that we are God's own gifts to creation, there needs to be some amount of humility to understand that scientific experience requires a long investment of study of decades, and also that while we may be able to provide the platforms and the analysis tools and so on, for us to claim that we also understand the underlying science is a bit of a stretch. So in much of the what you see in all the advertisements in the journals and the newspapers, they all say that, okay, as long as you learn these tools, now you can become a data scientist. And as I mentioned, the key thing to remember here is that science is the key word, not data. And once that is done, then certainly this is a extremely powerful weapon that you have, which could be used judiciously to actually do much better science than before.
Thank you. Thank you very much.
Thank you, Professor Mudkavi. Now I would like to call upon Professor Gopal from Anna University to join the conversation with his question to Jayant.
Yes, sir. Thank you very much, Professor Jayant Haritsa. It's a pleasure to listen to you again in this forum. Data per se banks on instrumentalism, which is anti-realism. They don't align well. So when we are talking about data per se, we are moving away from realism. Is one observation. Your comment is welcome. And once we start using data in that context of anti-realism, whatever expertise we are putting is primarily on a synthesis, a synthetic data. And how do you comment about results based on synthetic data?
Okay, to start off, I didn't understand all the philosophical terms that you used in your question, but I would just comment that I don't think that data is moving away from reality. We as scientists are moving away from reality. That is the problem. The data by itself is, I think, fairly immune to such errors, because you are actually using these various kinds of sensors to measure real world phenomena. Like I think Professor Mudkavi does a lot of it. You are looking at turbulence, you're looking at flow, you're looking at temperatures, pressures, and so on. And I don't doubt the validity of the sensor information itself. The question is that what do you conclude from it? So it's the subsequent part of processing the data and doing analysis, which is dangerous. Synthesis certainly makes a lot of sense in terms of that you want to combine this raw data into some kind of summary structures. And without doing that summarization, it's often impossible to make sense of the whole thing. But subsequently, would you be then tempted to draw incorrect conclusions like the one I showed you about the Olympic gold medalists? Whatever data had been shown so far was perfectly right. The last 100 years, all those, the timings that have been shown are perfectly correct. The danger is that you have subsequently extrapolated it. So if you're starting to do prediction as opposed to analysis, which is what good old-fashioned statistics was doing, once you get into the predictive world, then we are in more uncertain territory, because it is not clear that the conditions that are true now would also be true in the future, and would therefore allow you to make those extrapolations. So we are making these wild extrapolations based on historical data, and predict the future based on the past is, as we all know, something which is usually fraught with various kinds of errors.
Let's just forget the exact terminology, but it's very nice answer. Thank you very much. We need to perpetuate all paths. We need, the ground reality is that having come to such a pass that we have done something on synthetic data, we have done something on measurements and instruments, we will have to perpetuate it up to some point. We cannot drop it suddenly. That's the realism. Then what do we do? That is the concern.
Yeah, so again, as I said, I'm not recommending at all that we should dispense with the data. The data is actually very useful. It's just that we are saying that there's a warning label saying use with care.
All right.
That's all. Okay, and use it with the domain scientists, because as I said, the computer scientists now seem to feel that they have a halo around their heads, although I'm part of that community, that we know best. And you just give us the data. We don't need the chemists or the physicists anymore. The scientific premise itself is not required. Through data, I can learn everything. And I think that is, again, an extrapolation that is hard to substantiate. Okay. So the job opportunities for the basic scientists will remain for quite a while, even though they might feel threatened at this point in time.
Okay, thank you, Professor Gopal. Now I would like to invite Mr. Nagraj Kulkarni, founder and CEO of Computations, to ask his question and join the conversation. Over to you, Nagraj.
Thank you, Professor. Professor Jayant, Pleasure hearing to you, as always. What caught me attention is, does big data ask you asking worthy questions? Does big data also make the processes victims of the computers? Is a question. You mentioned about 9% of a caffeine, and we are seeing a lots of live cases of it, like in a Whitehead Junior. Some kid is supposed to be learning, all those three things you mentioned, programming and algorithms and business logic and a lot more, and become a CEO in a 6 months or a 1 year time. And we are seeing that everywhere. I personally have been in a situation to inaugurate some big data analytics program, and the people who were admitted didn't know the concept of an ABC analysis, 80-20 rule. They had no clue about it. Okay, so in a world like this, where increasingly everything becomes a victims of programming, what could be done to prevent that? What could be done so that the common sense does not become a victim of bad algorithms?
Right. Yeah, I couldn't agree with you more that unfortunately, thanks to IPL, we seem to have fallen into this mode of instant gratification where everything has to happen overnight. We want instant PhDs, we want instant, as you said, CEOs and so on, without realizing that to achieve anything really useful, you need to pay the dues to the domain and understand it well. But often this is lost on the public at large because everybody feels that they should have gotten whatever they're hoping to get yesterday and not even wait for tomorrow. So one of the things that I would say is that it's very important for all the data science companies to also explain to their to the employees that they're hiring is that they need to have at least a couple of years foundations in basic mathematics and statistics. And it is not just enough to know saying that I know Python, so now I can essentially take on the entire world. That the programming is actually the least important part of all of this. It's certainly a useful and necessary adjunct, but first you need to have a foundations so that you don't make wrong conclusions. So unless they have done a couple of years of statistics, they should, and hopefully here Professor Bhogle would agree with this because he's primarily a statistician who's been working on monsoon prediction and so on, is that you need to pay your dues. And once that is done, certainly, of course, you can help with various domains. But if you say that I can do it in a 3-month boot camp and actually become the master of 3 fields, we are actually selling snake oil and at a fairly expensive proposition currently. So it's important that we tell our students and that it's important that they need to spend the years learning these fields to make sure that they don't fall prey to mistakes. And it's not just a tool-driven science, it's a real science of its own.
Great. Thank you, Professor.
Okay. Thank you, Nagaraj. Now I would like to request Dr. Srinivas Bhogle to raise his question and then for a discussion following that. Over to you, Dr. Bhogle.
I think you're on mute still, Professor Bhogle.
Hear me now. Now I'm.
Yeah, now it's audible.
Right. Yeah, so good to listen to your talk. I was kind of expecting something like this.
Okay.
And I'm delighted that I got it. Okay. Couple of observations first. I mean, when you talk of the good, bad, and the ugly of data science, I'd ask you to juxtapose just science instead of data science. And then in science, I believe if you look around, or even if you don't look too hard, you will still find the good, bad, and the ugly. So really, why would we pick out data science in particular? I mean, unless it's reflective of bias. And if there is a bias, then I should worry about that. The other small observation is that, all those quack courses that you talked about, in 3 months to learn this, and they're quack courses. They don't represent true data science. But again, if you look at the market and if you look at the requirement, I mean, we've had this before, right? Didn't we have Unix and C? Everyone was supposed to learn Unix and C, and computer scientists, what is really Unix and C and what was taught in those courses.
And then we had what, SQL and DBase3 earlier, and then what, Oracle. So we went through that process. So really the point I think I'm trying to make is, if there is going to be a huge market for data science, I don't think every participant in this market needs to be a hardcore data scientist. So these 3-month guys are really more like car mechanics. You see, I can give someone a 3-month course in car, repairing a car, and he'll probably do it better than I can, because they open the bonnet, they know what to look for, they find it, and they fix it. Otherwise, they don't find it. So, but you need car mechanics. I mean, you can't have an automobile industry if we didn't have car mechanics. So I see that in that perspective. But eventually, of course, the other one, which I must disagree rather more strongly, is when you say that statistics is essentially exploratory, or in the jargon, you might call it descriptive statistics. That's not quite true. Historically, statistics has always been descriptive and predictive. In fact, as a part of your talk, at one point, you let slip conditional probability. I heard that word. I was quite delighted to hear that.
That's okay.
Because that really meant that what is conditional probability? You're trying to make, posterior estimates based on, you have prior estimates to start with, and then, system evolves and you're gathering more information, and that extra information gets sort of incremented to your initial estimate, and then you get better posterior estimates. In fact, the whole Bayes theorem is about that, computing posterior probabilities based on some prior assumption. It is predictive, undoubtedly predictive. And finally, I think the last big point, and really the big point, is that, you see, data is exploding. I mean, there is some law, right? I don't know whose laws are named after some people, but Murphy or something, data doubling itself every 2 years and so on. We've heard all that. The big point is that in the past, when we were students, the only way we could gather data was, devise a questionnaire and go to some school or go to some factory and gather some data and do some mean standard deviation, that kind of thing, because data didn't come to us. We had to go to the data. Today, the situation is that the data is coming to us, and it's not just coming slowly or, mild, it's coming in gushes and torrents and avalanches. The problem is, and clearly, even a man of science would be wise enough to realize that if I'm getting so much data, there must be some insight, some wisdom, something inside that data. And then he realizes that the tools that he has today are inadequate, insufficient. What do you do about it? So that really is the beginning of, really the key motivation for data science. I'm flooded with data using traditional techniques. I really don't know what to do with it. And therefore, let me try look for newer techniques. And really the success, it is hyped. Everything is hyped. I recall mathematical chaos was hyped. I recall that I don't know that, but chemical fusion was hyped. Hype, and big data was hyped. And ironically, big data hype and all the examples that you mentioned, New York Times, Washington Post, it's essentially a question of somebody making bad inferences. Now, I agree that the linear regression fit was working. You said yourself it's based on that data, but I think it was sheer foolishness to presume that I can extend that line ad infinitum and go to 2156 or whichever year it was. Indeed, to assume that there is a linear fit is because you said at one point, the curve is kind of straightening up now. So you're saying that already you're beginning to discover a departure from linearity. Right. And all these regression coefficients, logistic regression, anything you talk about are linear. The correlation coefficient is a measure of linear dependence. And most people do realize that linearity goes up to a point. It's a great place to start, but obviously not the place to end. So I see data science as a situation where we have overwhelming data. And we have strong suspicion that there's something coming out of it. And then how do we do it? Another one last thing, I'm going to stop because I know you will stop me before I stop. It's that I was expecting you to mention neural networks somewhere, because I know neural networks are ridiculed. I know back in 4PI when it was called CMAX, we ridiculed it ourselves. But the case was different then. There was just not enough data. Now there is. And with neural network is presumably the network of choice for learning. And we all agree that the more the data comes in, the better becomes our learning. And really that is why the excitement is around. Machine learning, AI, excitement is also good for the economy. Because you're going to have more people working on it. And if more people work on it, more good people are going to come out of it. So really, that's all I have to say, Ali.
Thank you, Dr.
Okay.
Bogle.
Yeah, I don't know where to start answering, but maybe I'll start at the beginning because a very important question that Professor Bogle raised, saying that, look, the same kinds of criticisms that we have leveled here at data science could also be leveled as just the scientific system itself. So why are you singling it out for this kind of treatment? So all I would point out is that what you're saying is absolutely right. There is a lot of bogus science going on as well, but it's much easier to come up with wrong conclusions because of the facility that you have now. So data science encourages you to do this bad and the ugly in a much simpler way because you don't even have to go and get the data. As you said, it comes in tsunamis right to your doorstep. You have the computing power to come up with something through it. And it's much harder for somebody else to check. Because one of the interesting things is that when you have so much data and you come up with some metric on it, it's very hard to judge whether it's really correct or not. Even let's say there's a mistake in your program itself, and you are computing some summations or averages or variance or some other moment of the distribution, it's very easy to make mistakes because the volume is so large, you essentially become submerged under the information you have. Whereas the prior statisticians would have some kind of a gut feeling saying that they should be in this range or it should be in that group and so on. And if the numbers did not match with that intuition, they would go and again look and see whether their mistake might have been made. So now the gut feeling can easily become subservient to what you're getting from data that is hard to comprehend, but somebody is saying, look, it's that's what the data says, and who are you to argue against it? So all I'm saying is that the criticisms could certainly be leveled against science itself, but data science makes it much easier to, in some sense, come up with wrong conclusions. And even the regression that we showed you earlier, that actually came in the Nature journal itself. So it was not in the Deccan Herald or in the Indian Express. That came in very prestigious journals like Nature and Science and so on, which are considered the acme of the scientific research community. So even people who should have known better, as you said, are tending to make mistakes just because they now have the power to do it. So earlier people didn't have the power, now they have the power, and people who are not in a sense capable of using that power are being allowed to use it.
I agree completely. It's
Right,
easier to
right.
succumb to temptation now.
Yes, it is much easier to do that. Right. And the second point that you had raised is that about the statistics, saying that it has both an explanatory part about the past as well as predictive about the future. Again, I would certainly agree with that. And you also caught my thing about the conditional probability. What I just meant was that primarily, even if you look at the government plans and so on, much of the statistics was being used to look at, analyze what was happening in the past. And trying to look, for example, we had a very good Ministry of Statistics itself in the country, which I think Professor Balaram and so on and others had set up, and then also in ISI Kolkata has a very rich tradition of it. So it was largely looking at data that had already been collected, and you're trying to make sense out of it. But certainly there was a predictive element that was probably not used to the same extent. Now data science makes it fashionable to also do large-scale predictions to the future. And we also see that in
because there is more data now, so your predictive power is improving all the time.
Right, and the example I also wanted to give was which we were discussing yesterday, is if you look at the COVID as well, there are so many models that people have developed now from the various Indian academic institutions. There are at least half a dozen different dissemination models and spread of the disease models. And one of the difficulties is if you are a government secretary and said, look, how should I decide what is the right model? It's very hard to figure that out because all of them have different assumptions, different input data, and different expectations that they have about how things will subsequently behave. And the only thing I could probably say is that the one common thread that ties all those models is that they're all probably wrong. We don't know which one will be closest to the truth, but it's very difficult when you start doing this extensive predictions on data that is highly chaotic. So this is the third point that I wanted to make. You were talking about the neural networks, and I couldn't agree more that neural networks would be very useful for modeling things which are well behaved. But systems which have are in some sense volatile or are easily susceptible to wild changes in behavior based on a small change of a parameter, then so sensitive systems are not well handled by neural networks. And I'll give you an example from the area that I work in, which is in database management systems. There we have to do a lot of estimations of various kinds of statistics about how much data will come out given that you run a certain operation on them. So for example, if I say how many people are less than age 20 in India, I will be expecting that given the 120 crores we have, what is the expected number of rows that will come as the output for this particular question. And what we find is that we tend to make horrendous mistakes in this because we are not aware of the details of the data. We are doing some kinds of gross estimations. We are assuming independence between attributes. We are assuming uniform distributions, and we are making many other kinds of simplifying behavioral assumptions about the underlying data, which in the end means that the output that we get has no bearing to what is the correct value. And as we were discussing yesterday, we also see that in the elections itself now, where pretty much all the major elections in the last 10 years have been poorly predicted. We could look into the reasons why this has happened and so on, but even look at it now, the Biden versus Trump was badly predicted. Previously, Hillary versus Trump was badly predicted. In India, Kejriwal versus BJP was badly predicted. In Delhi, Jayalalitha versus Karunanidhi was badly done. So what it means is that just because I have a large amount of data doesn't necessarily mean that I have a monopoly on the truth. And therefore, we have to be careful that whatever we do has a proper scientific foundation and has been rigorously tested, including with external audits, before we come to some predictive analytics based on this information. So all that I'm saying is that there should be some caution in the use of it, and not just, I have a gun now, let me start shooting all over the place. We need to have some idea what is the proper targets on which we can use these extremely powerful weapons.
Thank
Thank you
you.
very much for your reply. Looks as though we are actually eventually in agreement, which is wonderful.
Right.
I just want to,
Dr. Bogla, I don't want to be an Arnab Goswami, but still we have to be mindful of the time, and then I will have to ask the next discussion.
So like they asked Arnab, I'm going to ask you for 30 seconds. And I don't think you are as cruel as Arnab to deny me those 30 seconds. Yeah, the whole point is, when you talked about election prediction, the real problem with election prediction is the model that converts the vote percentages to seats. The vote percentage to seat count models are wrong. And most of the results that you're seeing wrong are not because of poor vote percentage estimates, which is classical statistics, but the model that converts vote percentages to seats. And now,
right, because it's a Boolean comparison, Boolean shift that you're doing, right?
That's the trickiest part of election prediction.
Right.
And that's where they get it all wrong. Okay, I've stopped. Look.
Thank you. Thank you, Dr. Bogle, not letting me become Arnab Goswami, whom I don't like at all. Now, let me invite Hamsa Kalyani, librarian of NIAS, to ask her question and join the conversation.
Yeah, thank you very much for a fascinating talk, Professor. I come from this institute which does research in social science and humanities as well, sciences. So there are some challenges that comes in this practice, because librarians are actually involved in archiving data for reuse. But so what the social science and humanities research constitutes both qualitative and quantitative data. And raw data ranges from field notes, texts, interviews, surveys, films, documentaries, in addition to statistical data, and also audio, video recordings, and transcripts, and a whole lot of archival material that is used, photographs, images. So there is a range of material from which data is drawn, and the way data is created also. These are ways in which data is created also. So this is in addition to formal publications like journal articles, newspapers, and books, and different formal publications. And the range of data also is in multiple languages. So you see the complexity in social science data. So the question is, so there are many challenges, we can see that here. So the question is, basic questions are these, that how to recognize and define data in these diverse mediums. That becomes the starting challenge. And after having an idea of what data is, how to extract this data from diverse forms. That is also a challenge. How to validate this data, what is valid data, which is also a challenge. And then coming to interpretation. You have observations, insights, and all these data that you collect. The researcher actually puts forth his observations. So since interpretation, it's not so much about verification, it's more about interpreting the data. So interpretation is an important part. So is there a tension between interpretation and idea of data science? So I'm asking these questions because it becomes important in the context of data management plans of funding agencies, which requires researchers to comply with policies of data sharing. All the raw data, they are expected to share with the funding agency. See, during the research process itself, sharing this data is, it gives, the data management plan gives a workflow, so which is very helpful for researchers to share the data. But finally, to actually give the data for archival purposes becomes problematic, because this raw data collected cannot be reused. So, but there is a compulsion to give this data. And there are also ethical questions. You have to disguise the names. There are so many things when you give this raw data to the funding agencies. So, so this data management plan concept may work well with science, but may not work so well with social science, is what is being observed now. So these are some of the issues, some of the concerns of social science research. What are your views? I wanted to know.
Yeah, see, one thing that the social sciences has going for it is that they are inherently used to having a multiplicity of realities. And that's exactly the same data could be looked at very different ways, depending on the ideological stance from which you are coming. And for example, if you looked in the 20th century and all the French philosophers who belong to the post-structuralist school, they basically said that if you look at any document, earlier we used to celebrate the role of the author. And what people like Jacques Derrida and Susan Sontag and others said is that the author is dead. There are only readers, and not just one reader, multiple readers, and different readers can make different interpretations of the same text. So they essentially said the author is dead, long live the readers. Now, that was a very different school of thought compared to the past, where primacy was given to the author and it was considered that there was a single intent. There was a specific meaning that the author was intending. So if you look at Gulliver's Travels, is it just a story for children, or is it a satire on the existing society in England? You can view it in many different ways. So here, at least in the hard, so to speak, hard sciences, usually we expect that there's an absolute truth that is not conditioned on where we are coming from. Okay? Now, that may not always be fully the case, but there is at least some degree of minimality of outcomes that one could look at given any experiment that we have. Whereas the social sciences are rich with assuming that you can have many different outcomes depending on the context with which you're looking at it. But coming back to the other issue that you mentioned, that the data is hard to capture, that is certainly true, because in other fields like things like pressure, volume, temperatures, and so on, it's very easy to put a sensor and you get the value. But if you are having an image of a certain social strata, that is not something that can be converted to a number. And in fact, what I would actually say is that we shouldn't be trying to do it. Okay? So here I'll just take off on my pet peeve, is that you, as you would know, all the institutions are being ranked today by the government, including the academic institutions. And I think that is a terrible thing to do, because education is not a sport. Education is a process of self-transformation. It's a process of empowerment. So if you take a poor female student from some village and bring them to NIAS or to ISI or Indian Institute of Science, and they transform them to become a faculty at a top institution, like we actually have some students like that. I had a student who came from Sri Ganganagar, which is on the border with Pakistan and Rajasthan. She's today a very celebrated scientist at Columbia University. you have completely changed the perspective and the aspirational goals of that person. How can I go and give a number of comparing IIT Madras with IISc or with IIT Bombay? So, but somehow everybody loves numbers. But inherently, it is incorrect to even try to compare educational institutions because they all have their own roles to play. What you need to instead look at is where are the alumni of this institution now located? That will tell you whether you made a success or not. You don't need the MHRD or the NIRF rankings or the QoS and everybody else saying that you did a good job or not. Okay. So to give you a specific case, last year in the engineering disciplines, I think IIT Madras was a little lower than IISc, and this year it went one step above. And there was a lot of gnashing of teeth saying, okay, we have gone down. And I would say actually nothing has changed. IIT Madras is exactly the same it was last year. IISc is exactly the same that it was last year. We are all elephants who are slow to change. It's some small disturbances in the numbers that will produce different rankings, but they actually mean nothing. But we put a lot of emphasis on it, saying, am I number one in NIRF? Am I number two in it? And is there even a distance between the two? Because it's possible that I am 79 and the other person is 79.2, but they'll say I'm number one and you are a lowly number two. That's the kind of interpretation we put on it. When actually we are no different. Okay? And all the statisticians will tell you we come with large error bars around our measurements. There is no meaning to saying that these two institutions are really have a different strata to occupy. So there are a lot of such mistakes that we are making where we try to put numerical values to things that are intrinsically not suited for it. It's like asking for philosophy. Is Advaita better than Dvaita or not? Okay. Does Advaita rank as 1.3 and Dvaita is 1.5, or Vishishta Dvaita is 1.8? Does it make any sense? If we ask this question, it would look ridiculous. And I'm saying the same thing should be done with areas like education and so on. For sport, it's okay because there is a clear metric that you can have. But in many other fields, even in music, can you rank people? Okay, they're very different styles. So you should just enjoy it for whatever it has. So even in the social sciences, I think you should not try to convert them to numbers. That would be a fundamental mistake, to take something which is qualitative and forcibly bring it into a regime of quantitative values for which it's completely unsuited. And that's where your bias will also show up. Like I showed you with those music schools, there was a subtext there which said that classical music is good and contemporary music or modern music is bad. That automatically gets into the evaluation process. So we have to deal with uncertainties and look at things in a qualitative manner and what is the outcome of this, rather than trying to bring everybody into a common regime of numbers that could be fed into a neural network. So again, here I would say the question itself is wrong. Don't convert qualitative facets into quantitative numbers.
Okay. Yeah. Thank you very much. Thank you.
Thank you all discussants for your penetrating questions, and thank you Jayant for your calm and collected and of course very clarifying answers. Now we have some questions from the audience. We have some questions. I would like to pose them. This question is from Mohan HR. Could you please provide some highlights on open data across the globe, their impact, authenticity, and accountability? HR Mohan is from CSI, IEEE, CS, and I suppose you know him. So he
yes,
has this
we
question
have met before. Yes.
Yeah. No, that's the question. Could you please provide some highlights on open data across the globe, their impact, authenticity, and accountability?
I should actually confess that I'm not very familiar with to what extent these various data portals have become successful and are being used. But I do know that, for example, in Karnataka itself, the government has created an open data portal, and some of the faculty from IIIT Bangalore are involved in it. And they're especially trying to collect data related to both the land and property, which is probably the most crucial from both a societal and a government perspective. So they are doing that, along with also trying to bring in various kinds of privacy preserving mechanisms, which was also talked about before, to ensure that this cannot be used as a way to target people. But honestly, I don't have much idea as to what is happening on the ground with regard to to what extent people have used this satisfactorily. I think probably either Professor Mutkavi or Professor Bogle may have a better understanding because they actually dealt with the real data, like the monsoon prediction, election prediction, as well as the fluid dynamics and so on. So they might have a better understanding of this.
Professor Mutkavi, would you like to answer that question? Or
Well, specifically, for example, if you're looking at weather data, there is a established procedure for actually establishing that data. So, which may not be true with not every domain. Am I audible? I'm audible, right?
Yes.
Yeah.
Yes.
So for example, if you take, let's say, the process of putting out assimilated weather data, which I can use downstream for my simulations or whatever, goes through a very rigorous process. It is set up for a very long period of time, and then it is made open. So, for example, let's say the Karnataka state also has observational data for the rainfall. It is fairly authentic, but we do not know whether they are doing a rigorous testing of whether the data that is coming from these instruments are maintained or not. So there is very precise quality measures which are implemented in scientific data. I wouldn't know. I wouldn't have the same confidence in other data portals in the same way.
Okay. Thank you, Dr. Mutkavi. Now there is a question from Professor Chandrasekhar Subramaniam. If there are problems with the models, which subsequently we come to know, whom do we hold responsible?
Okay, that's a hard part. Maybe you can always say it's the professors who taught them who should be put in front of the firing squad. But it's often that this may have been done without deliberate malice, and all of us make honest to goodness mistakes. As long as they at least correct it subsequently and say that, look, what we did was perhaps inappropriate in light of what we have subsequently heard from, like as you saw in the chemistry example, then I think that's good enough that you have at least acknowledged that there could have been a mistake made. But if you keep trying to defend the indefensible, then I think that would not be a matching with the scientific ethic. So rather than worrying about responsibility, do we at least correct it for the future? Like you would see this, especially with climate change is the other case, which as Professor Mutkavi was mentioning, you have many different interpretations of it. And for example, you had even, of course, Trump was well known to say that climate change, what climate change? But even Michael Crichton was a person who felt that we were looking at too short a time window, and whatever climate change we are saying is actually a cycle that is occurring over much larger windows of time. So if you look at it over 10,000 years, then we are perfectly fine. There's no need to get so excited about the polar ice cap melting and so on. These are the usual cycles of nature. But if you look at it in a short term, then you'll say, oh my God, we may not be alive in 20 years time. Right? So I think we need to kind of look at this with some sense of balance, and also be willing to revisit our fundamentals in case there is some legitimate question that's raised about it. And mistakes will certainly happen. I mean, the whole of science progresses by mistakes, but as long as we are willing to acknowledge the possibility of such mistakes, I think that's the most important step.
Thank you, Jayant. This is the last question. Professor Sai Baba wanted to raise a question. Sai Baba, to you, please. Are you there?
I think he got tired of waiting for his turn. Right.
Okay. Otherwise, I think you can take that offline. So with this, we come to an end of the discussions following the lecture. Now, I would like to request our chair, Professor Balaram, to take over, give his remarks, please.
Okay. So thanks again for your patient listening.
I'd first of all like to thank Jayant for a most wonderful and stimulating lecture. I haven't spent a more enjoyable morning during these long months of lockdown. And part of the reason is that his emphasis on the bad and the ugly of what is associated with data science was music to my ears. I'm an old scientist trained in a classical discipline. And in recent years, I really watched with a little bit of apprehension how easily the terms big data, data analytics, machine learning, and artificial intelligence are being used and used in many different fields. There were two examples which stuck in my mind, which he gave, both of them from journals which me and my colleagues admire, Nature and Science. And there were clear examples of how common sense would have actually trumped both data science, it would have trumped any kind of model that you had. I, of course, also listened with great interest to what was the critique of Dr. Bogle. And I think this connection between statistics and data science was made at the beginning in a rather interesting way, where Jayant seemed to imply that people are using data science in a predictive way, whereas statistics was always used in the past, not in quite so predictive a manner, although it has been used, as Dr. Bogle pointed out. But to all of you who are listening, I might draw your attention to one very famous essay, which was written by the biologist Stephen Gould. And the title of his essay was The Median is Not the Measure. And he was actually writing about a prediction that cancer physicians make to their patients on life expectancy based on mortality curves. And Gould himself wrote this essay after having been told by his physician that he had 6 months to live. And then, of course, he went back and looked at the data and decided why should he not be on the very extreme end of the curve? And happily, he lived 19 years after the initial prediction was made. So individual behavior, of course, is not easy to predict. Lastly, I might just say that I was really struck by one phrase which Jayant used, and that was he called data science statistics on steroids. After having listened to his many examples, I thought it might be more appropriate to call data science statistics on marijuana, about which we have so much of a discussion nowadays. Just legalized in America and still a subject of heated discussion in India. Finally, I want to thank Mr. Satyanarayana, Shalini, and all the other colleagues for having invited me to chair this session. Thank you very much.
Thank you, Professor Balaram, for your thoughts and as well as bringing the marijuana to the picture so that we all end this on a high note. So now, thank you so much. And now I would like to request Dr. Meera to propose the formal vote of thanks. Over to you, Meera.
Am I audible?
Yes.
So good afternoon, everyone. All good things come to an end, is the quote. Now we have come to the end of 17th annual lecture of Informatics India Limited, delivered by Professor Jayant Haritsa from the Department of Computational and Data Science, Indian Institute of Science, Bangalore. As a protocol, the program will end by proposing vote of thanks, and I am privileged and honored to do this. First and foremost, I would like to thank Professor Haritsa on behalf of LTC organizing partners, that is Informatics India Limited, National Institute of Advanced Studies, CSIR 4th Paradigm Institute, and Rajiv Gandhi Institute of Health Science, all from Bangalore, for your thought-provoking deliberation. I personally thank Professor Haritsa for making a debatable presentation which led to a lot of discussion by addressing bad and ugly faces of data science and let us know how it is misused. And he left the discussants to discuss the good part of data science. That's one good thing. Professor P. Balaram, a well-known academician, scientist, and administrator who was former director of the Indian Institute of Science, Bangalore, has chaired the session. Sir, I thank you on behalf of all the LTC Conclave 2020 partnering institutions for your thought-provoking remarks. We had 5 discussants who had contributed intensely in making the session highly interactive. They have brought in spark to the whole event. I thank each one of you for your great participation. I take this opportunity to thank all the invited panelists. The most important entity in a session like this are the participants. I understand that there were more than 700 registered participants, but finally more than 270 participants have virtually joined us. Friends, without your participation, the event cannot be considered successful. I thank each one of you for making this event a memorable one. I take pride in thanking today's Master of Ceremony, Professor Shalini Aras. She has done a great job in moderating the most lively and debatable outcome of this annual lecture series of informatics. On behalf of Informatics India Limited, I profusely thank all the conclave partners, that is National Institute of Advanced Studies, CSIR 4th Paradigm Institute, and Rajiv Gandhi Institute of Health Sciences. Lastly, I thank all the core team members of Library Technology Conclave for their valued support throughout. And before I conclude, dear participants, please stay tuned for the forthcoming events of LTC in the new year 2021. Thank you all.